Hey folks, welcome back to the show. We have a great episode for you, longevity enthusiasts, today. As we're talking about longevity and optimizing our health, what better topic but to talk about testing for your biological age. In this episode of the Biohacking Superhuman Performance podcast, I chat with Hannah Wendt, the Director of Operations at TruDiagnostic, about the stories certain biomarkers can tell about our present health and our future health. From predictors of lifespan to predictors of disease, there's a huge array of biomarkers that we can target to help identify a person's biological age. Hannah also shares what lifestyle changes someone can implement to increase their longevity and reverse the clock on their biological age so that it either equals or surpasses a person's chronological age. Or actually, you want to underpass your chronological age. You want your biological age to be lower than your chronological age. So we can do things like limiting alcohol consumption or caloric restriction. There are a multitude of lifestyle changes one can make to increase their lifespan, and let's not forget about health span. Hannah Wendt has a lifelong passion for longevity and breakthrough disruptive technologies that drive radical improvement of the human condition. She attended the University of Kentucky and graduated with a degree in biology. After graduation, she worked for the International Peptide Society as their director of research and content. So through work in the integrative medicine industry, Hannah saw an opportunity for methylation-based age diagnostics. If that's all Greek to you, don't worry, we explain it in the podcast, and started TruDiagnostics in 2020. I've always been incredibly impressed with Hannah. She looks super young, but man, she knows her stuff. And she just looks young. Maybe she's not as young as she looks. But TruDiagnostics is a company focusing on methylation array-based diagnostics for life extension and preventative healthcare, serving functional medical providers. And they also are doing a ton of studies with different supplements. As a matter of fact, I believe that MitoPure might be doing a study with them in the next year. So to learn more about Hannah and to order your own TruDiagnostic test, you can go to TruDiagnostic.com and use code longevity12 for a discount on whatever test you choose. And also you can follow on Instagram, TruDiagnostic Official, and that will give you lots of information on the test and the new things coming down the pipes with them. If you want to follow Hannah, she's actually launched a new podcast called everythingepigenetics.com. And her handle on Instagram is also Everything Epigenetics. I know that you're going to enjoy listening to Hannah. She's so fun. Thank you for your comments, your questions, all of the incredible feedback I get from you guys. I so appreciate you. And if you get value from this episode or any episodes, please make sure to share it with your friends and networks. And of course, if you're looking to connect with me, all those links are in the show notes, but you can find me at natnidham.com on my website. And that's where you can find out about all the podcasts that I do, the women's retreat I'm holding in November, and also my private community on Mighty Networks. So thank you again for being here. And if you're feeling inspired today, please make sure to leave us a review, because that's what allows us to climb up that ladder and get amazing guests for you. All right. Thanks so much. Let's dive in to TruDiagnostic and biological age. Hey folks, just a quick reminder that all of the information presented in this podcast is for information purposes only. No medical advice, no diagnosing, no treatments suggested here. Before you try anything that you hear about or learn about here, make sure that you check with your medical provider. Hannah Wendt, welcome to the show. This has been I think it's taken us a year of scheduling, rescheduling, and scheduling. Thank you so much for finally making it here. I'm so excited about this conversation.
Yeah, thanks so much for having me, Natalie. Super excited to be here. I know, like you said, we've been pinging each other and going back and forth. So super excited to chat with you today.
Yeah, no, me too. And you know what? In a way, with someone like you, especially because you're in such a fast-moving field, every delay is a payoff, because something new happens, you develop something, you learn something, some new test comes out. So, in some ways, it's kind of like pulling the slingshot back exactly to that right sweet spot and then letting it go.
Exactly. The more time, we wait, the better, as we have all these new insights and projects and products that are being launched. So I think this is a perfect time though.
Me too. Okay, good. I'm glad we both agree on that. So for you guys, unless you skip through the intro, which some people do, that Hannah Wendt works with TruDiagnostic, and we're going to talk today about not just the TruDiagnostic test, but we're going to get into what all these metrics really mean. And maybe we're going to talk a little bit about a few of the other tests that are out there. There's a lot of confusion, like with, you've got a GrimAge test, you've got a TruDiagnostic test measuring your telomeres, then you've got another one measuring your pace of aging, then you've got this other one measuring your DNA methylation clock, and then you're like, okay, am I younger? Am I older? Like, am I good? Like, a lot of people are like, am I good? So, and if they're not good, I think a big piece of the puzzle, certainly for me when I'm working with clients, is getting them to calm down and go, you know what, it's okay. Like, these are all, for the most part, as far as we know right now, these are solvable problems. These are things that if you are willing to make certain lifestyle changes and maybe take a few supplements and whatnot, we can probably at the very least slow things down, if not reverse them. So anyway, that's the big intro. Maybe what we want to start with, I'm trying to figure out where we're going to begin this, but I think maybe one of the things we were talking about earlier is how there's these first, second, and third generation clocks. And so maybe what you want to do, Hannah, is talk a little bit about the DNA methylation test and those multi-generation, those clocks, and what might be coming down the pipes. I think you have some really interesting stuff coming down the pipes pretty soon. And then we'll move on to the Dunedin pace of aging and the telomeres, because I mean, just that suite of testing is just such fascinating information for people.
Yeah, definitely. And I think echoing, Natalie, what you said, just backing up a little bit, all of these tests, I want you, everyone listening to think of these as biomarkers. That is all they are, right? Everyone knows, hopefully what a biomarker is. And that is what biological age is, essentially. So we even like to talk about, the epigenetic methylation testing that we do. And I'll explain that for those who may be new to the subject. It's just a biomarker. So as Natalie stated, there's all of these biological age tests. There's your glycan age, your telomere length. You can discover your biological age from a blood-based test. So, what looks the best as a true aging predictor on the market, because all of those other things are still great, but they're probably a biomarker and maybe a biomarker of something else. Mm-hmm. So the epigenetic methylation testing that TruDiagnostic does look to be the most, precise, accurate, sensitive type of way to look at biological aging. And what that means is epigenetics just means above the genome. That's what epi means. It's a Greek prefix. So we're looking at markers on top of the DNA. We're not looking at genetics. We're not looking at your SNPs. We're not looking at MTHFR or COMT genes, where people typically think of that when they hear methylation. Yeah. But we're looking at just a DNA methylation marker on top of the genome. So a CH3 group, a carbon and 3 hydrogens. And what happens is that controls the expression of your genes. So if something is methylated, if something has that CH3 group on top of it, that gene is not expressed.
Nice.
And it's very site specific. So think of it like light switches, right? The light switches that light up the room, we're controlling, what's being lit up in your genome, what's turned on, what's turned off. DNA methylation is very site specific in the way that you want some things to be turned off and some things to be turned on. So, you want your oncogenes or your cancer genes to be turned off, right? But you want your tumor suppressor genes to be turned on. Mm-hmm. So it's this healthy balance of DNA methylation. And what Natalie talked about, there's under epigenetic methylation, there's all of these different biological age clocks that we're going to categorize for you today. And really the first type of clocks, these are called first generation clocks. These came out in about 2011 and 2013, Dr. Steve Horvath really pioneered all of this. He's a biostatistician out of UCLA, and he'll probably win a Nobel Prize for his work in the field. It's really, really exciting. And we could not be where we are today without his work. What he found was a very, very high correlation between your chronological age. So that's important there, chronological age, and your methylation markers, like an R-square value of, above 0.95. And you just do not see that in science. So that was groundbreaking. But go ahead, Natalie. Sorry.
Yeah, I know I'm going to put my hand
rambling.
up. I don't want to interrupt you. I don't want to kill your flow. And I want to just sometimes back up and answer.
Yep.
Somebody might be sitting there going, what's an R value?
Yeah, exactly.
I know what it is, but what's an R value?
Yeah. So an R value is just taking, two variables and looking at how highly, correlated are. to one another. So just a little statistical term there, but you want to be higher. You want to have a higher R value. So 0.95 is, very, very significant.
Yeah. So it's like a 95% correlation between the two. Right. And so, and again, for people who are new to this space, your chronological age is what your birth certificate says. Your biological age is what one of these tests is going to tell you, which ultimately is an indication, a rough indication or some kind of indication as to, is your body aging faster or slower? So are you a 40-year-old showing up as an 80-year-old, or are you a 40-year-old showing up as a 20-year-old? Those are very extreme situations, but I just thought I would clarify that. And now I'm gonna let Hannah loose again.
No, exactly. There's just so much to talk about. It's really hard to kind of like start and pick those points. So just cut me off if I need to be more clear.
I'll just put my hand up. That's
perfect. Perfect. So in 2011 and 2013, these first biological age clocks that were created are called first generation clocks, just a definition.
Yeah.
And the way they create these first generation clocks is they're actually trying to predict your chronological age by looking at your methylation markers.
Okay.
So you're still getting this outcome of age. It's called biological age, but that was the goal of first generation clocks, is to just predict what's on your birth certificate from looking at methylation, from looking at markers on top of your DNA. Now, that is still huge, because if that first generation biological age is above your chronological age, you are at increased risk for a lot of different chronic diseases and death, according to the literature, right? So those are still really, really important. A little kind of side note, they were also used to, understand the ages of refugees, to see if they were old enough to seek asylum. They use those first generation clocks to identify the age of people from different crime scenes. So, they still have great utility and application, right?
Yeah.
Just depends what, if you want that outcome, right? It's still important.
Okay, I have a question. So if we're looking at DNA methylation patterns, but that tells us that I'm a bit confused, because when I read my report, it tells me my DNA methylation pattern is showing that I am X years younger than my chronological age. But you're telling me that the first generation clock looks at the DNA methylation patterns and says that I am this age chronologically. So are they just looking at different DNA methylation marker sites, or
Yeah, that is confusing. So the first generation clocks, that's a great question. It's still considered a biological age. So you're still getting your biological age from that first generation clock, but they're just trying to predict and get as close as possible to your chronological age. So just in the way that they were built, they're trying to predict chronological age, but they're still giving you a number that you would consider your biological age. Okay. So the terminology is a little bit confusing there, but it's still a biological age predictor. Mm-hmm.
Okay. But it has a tendency to be super close to chronological age on that first gen clock.
Correct. Maybe, depending on if you're, aging faster or aging a little bit slower, but yes, that would be the goal, is to try to predict that. But obviously, and we'll get into that, your lifestyle factors, different supplements and things can have an effect on those. Mm-hmm.
Okay. All right. So that's first generation clocks. The goal being to try and figure out, and I guess really as a baseline to the development of the future clocks, if we can get close on a person's age, then, and almost use that as a benchmark, then the future clocks, we're now leveraging the information differently to get different types of data.
Exactly. So, fast forward about to 2018 and 2019, Natalie, what you described is exactly that is what's happening. So, in 2018 and 2019, these new clocks were created, still looking at methylation markers. These are called second generation clocks. And these second generation clocks are actually going to add in an underlying age-related biomarker to predict your biological age. So I'll list some examples of that and go through. For example, there's Dr. Morgan Levine. She was actually Dr. Steve Horvath's postdoc at UCLA, went to Harvard, and now they're all at Altos Labs, studying cellular reprogramming. But she has this clock called PhenoAge. Mm-hmm. And it's looking at methylation, but it's taking in some lab-based values that you would, receive back from a blood-based panel that your healthcare provider would give you. So it's looking at methylation plus the blood-based values and giving you a biological age without using, chronological age.
Okay.
So those are going to be better predictors of biological age than those first generation clocks. And how do we know that? Well, the reason we know that is because those second generation clocks are actually going to be more tightly correlated to disease outcomes and death and more predictive of almost every single chronic disease and death as well. So it's like you're adding kind of like another layer of information.
Well, and it makes sense, right? Because you're doing your blood work and it's showing at this time, right? Your blood sugar, I don't know what they look at specifically, but let's say it's your blood glucose, your HbA1c, your inflammation markers, your blood lipids. So at this moment in time, given your DNA methylation pattern and those realities, this is where you're at. That actually makes a lot of sense to me. Mm. What I would imagine is really inspiring to people is those blood markers can be shifted. And so as you shift them, I would imagine a big part of the work they've done is they said, and when you start to shift these markers in a positive way, you get to see an improvement in that biological age.
Exactly. That's exactly the idea. And that's a really good example. I love Morgan's PhenoAge. That's probably considered one of the best right now. The one that is maybe considered a little bit better, that one's going to be Dr. Steve Horvath's GrimAge. It's actually,
but nobody wants to know that.
Right. I wouldn't want to know it personally. And it's really hard to interpret actually. But that's a death predictor essentially. And that second generation clock uses protein values, so proteomic values, on top of the methylation to predict, this biological age. So that's like a really popular one in the space. And then there's DNA methylation, a telomere length biological age clock, right, where they're adding telomere length and the methylation markers to give you a biological age based on that. So you have all of these kind of factors that can, of course, affect those second generation clocks or be layered in with that methylation.
Beautiful. And so just to go back to the GrimAge, because you were going quickly at that point. So GrimAge, you guys, is a predictor of age of death. Mm-hmm. And it's believed to be so accurate that for the most part, people don't want to know. They don't look at it. And I don't know, do we know how changeable or if it's changeable, or is the belief that it's not changeable? I can't imagine it's not changeable. Like, how is that even possible?
Yeah, definitely changeable. That's one of, I would say, the clock that's really highly cited in the literature. There's even a quote, I haven't said this in such a long time, but I just remembered it, that it's more likely for a asteroid to hit Earth than it is for that GrimAge algorithm to, not be predictive, is because it's basically, a statistical math problem, essentially, is what it comes down to. So they're able to, make some pretty strong statements there. But forgot that statement, but that has been said before.
but it can be changed, but you can influence it by changing things. So I guess at the end of the day, people who want to know their GrimAge, it depends on your personality type. If you're the kind of person who's going to lie awake at night worrying about the fact that you're going to, your results came back and showed that you were going to be done in X number of years. If you're a person that's going to lie awake and just ruminate about it all night, thereby possibly making the clock wrong and dying earlier because of lack of sleep and stress, right? Whereas then you get other people that are super analytical and say, okay, cool, good to know. What do I need to do? And they're off to the races. But all right, so that's really interesting. So that's GrimAge, which is part of the family of second generation clocks.
Correct. Yeah. And, so those are the first and second generation clocks. TruDiagnostic, the company I work with, they are, or I should say, we are not impressed by the science, right? We're always achieving more. We always want more. We want to push the boundaries and push the limits. We hold ourselves to the highest scientific integrity level that there is. So really, since we opened, we've been working on a really exciting project with Harvard, where we're going to push the boundaries, push those limits. And we're taking about 5,000 biobank samples from Brigham Women's Hospital at Harvard. And what we're doing with those samples is, this will be a list here, but we're looking at their epigenetics, their genetics, their proteome, so their protein levels, their metabolomics, their different metabolites, a little bit of transcriptomics, and their phenomics, so these phenotypic outwards expressions. We're taking all of that data and creating what is hopefully going to be the best second generation clot created to date. So it's talking more about this multi-omic approach where, again, as you add like these layers on, the better the predictors become.
Question.
Yeah.
Can you give us examples, just one or two of each one of those? Proteomics, metabolomics. Is that too deep, or
no, like just like a list of
what's a
like
metabolomic for, like what's a metabolomic, like an example of a metabolomic? Like, is that looking at blood sugar, or is that looking at something a little more complex? Or like a proteomic, is that looking at misfolded proteins in a certain area? Or
correct. Yeah. So, you have, let's start at like the top of this kind of central dogma, right? So you have your genetics, right?
Yes.
That's your DNA. That is your genes. So we get their genomic information, right? Which is really cool. That's not changeable, right?
No, that's your blueprint. We call that your blueprint.
Exactly. So that is going to be your genetics. The second layer is I mentioned a little bit of I mentioned a little bit of this, but it's going to be more of your transcriptomics. So the transcriptomics is going to be more of like your RNA processing. So those are going to be different RNA levels, and it's going to help your protein folding and kind of go through that process.
Perfect.
That third one is going to be the proteome. So the proteome is going to be just this how proteins are folded in your body, right? So there's all these different types of proteomes, and we're using actually a company called SomaLogic at our laboratory to do untargeted proteomics. So we're not only just looking at, hey, what's floating around in the body, we're trying to identify, all types of different protein levels, things like your different antigens and what's being expressed at that level.
Yep. Great.
Then you have your metabolomics coming, and those metabolomics are going to be metabolites. So these are, these are going to be foreign substances, such as drugs and different metabolites floating around. So it's this substance, like think of it like it's being made when the body breaks down certain food, drugs, or chemicals, or its own tissues, like your fat or your muscle tissue. A lot of information. I know it's a little bit overwhelming.
No, but that's okay. I mean, it's good to, so it's like downstream metabolites. It's your body is processing a bunch of stuff, and then this is the outcome. It's like when we look at when we're looking at whatchamacallit, the estrogen, the sex hormone test. Why is it escaping me right now? That's looking at the downstream metabolites of your sex hormones.
Correct. That's a good example. Yeah. I don't know the name. Sorry.
I do know the name because I just did it. I literally have it to send out. And I know the name because I know this test so well. And for some reason, the only test name in my head right now is TruDiagnostic. It's displacing everything else. Anyway, but it's like, your body, you have all these hormones, and your body, depending on the different pathways that are active and different things, is going to take estrogen and push it down the 2-OH, 4-OH, or 16-OH pathway. Those would be those metabolites. So,
yep,
okay.
Definitely.
So that's metabolomics. Cool.
Yeah. So the whole point being that, we're gathering a lot of data, right? And for those current second generation clocks I just named, there's only one of those, omic factors included. So we're taking, I think I named about like 5 or 6 different ones and combining them. So again, the more layers you have, the better predictor it becomes, because we want it to be a true biological signal. Right. We need it to be reflective of what's currently happening in the body. So, hopefully we'll have that paper published here within, the next couple of months or so, and then have that available as an outcome on our reporting too.
Nice. And so will you be able to get all that information from the current method that you're using to sample, like for blood, let's say? I mean, because right now you've got this great it's a blood spot. It's a big blood spot. It's a blood spot. It's a giant blood spot test. But would you be able to use that as well? Not a blood draw?
Correct. We will, because we already have your raw data, right? So it's forwards and backwards compatible. As you know, we dig up old things we find that are really cool or create new things, then we'll be able to give you that information.
That's amazing. Okay, cool. All right, so keep going. So then our third generation clocks coming down the pipes at you soon.
Yeah. So I define, first and second generation, and those are great, but they are still a little bit limited in the fact that they tell you your overarching biological age, right?
Mm-hmm.
And that's, I call it this historical processing. I made up that term. But I think it does a really great idea of capturing what it means in terms of really your aging starts at your inception, and it's capturing everything that happened up until this current time point. Right. So if you get a biological aging test back and you are older biologically compared to your chronological age, that can be really frustrating because, people may freak out and say, oh my gosh, I'm older. But the truth is that accelerated aging could have happened when you were 5 years old, 20 years old. I don't know, whenever, maybe you were doing something that's not great for your health, right?
But for example, what are some of the things, what are, for example, some of the things that we believe or know can accelerate a person's age? Like, for example, getting cancer, going through chemotherapy, I would guess that's going to accelerate a person's aging process.
Exactly right. Any disease diagnosis or even phenotypic outwards expression of the disease, when you can start to see kind of different signs and symptoms of that disease, would accelerate the biological aging clocks. That's very heavily validated in the literature and research. Lifestyle factors that absolutely speed up the clock are going to be smoking cigarettes. That's probably the strongest correlation and signal between, any lifestyle factor in your methylation markers. And then secondarily, alcohol consumption. So people who have AUD or alcohol use disorder, which is about 7 drinks a week for women, double that for men, have about a 2.22 year epigenetic age acceleration on average.
That's so amazing, really because that's not even that much alcohol. I don't drink much. If I drink a glass of wine a week, it's a lot. It's just not my thing. Yeah. But not to sit on my high horse. It's just, I'm fortunate that I don't love the stuff. So it's easy for me to say no. But 7 drinks a week for a woman it's not that much alcohol if you think about it.
I don't drink much either, which I'm fortunate. Just no interest really. But when I do go out and I don't know, I have friends in town and I want to drink or, have, let loose and sit back and have fun. Yeah, go with the crowd. 7 drinks is not that much, right? And then if I
had 7 drinks, I'd be on the floor. Yeah.
Over the course of a weekend. But so you get to think about it and you're like, wow, did I, you're counting your drinks and stuff. So it can add up fairly quickly is my point, right? So it's like, whether you have them all in one Saturday or whether you have them across that week, it's still 7 drinks per week, right? So it's something that, I think I've been more hyper aware of just because of the literature and being like, it's scary to kind of think about.
Well, certainly when it's a lifestyle, it's a way of life, right? It's one thing if once in a while, like you said, you have friends in from out of town, you're going to drink a little more this weekend than you normally do.
Yeah.
Probably not as big an impact as people where this is their way of life and this is just what they do week in, week out, month in, month out.
Correct. You're exactly right. Yeah. More of this, social situation.
All right. So smoking, booze. What about stress? Like chronic stress?
Oh, that is one that hits home for me because I'm just a naturally stressed out person. And it absolutely increases the biological aging process or, speeds up those clocks. So it's really funny. My best friend came up to me the other day and was like, was getting married and was like, is this what anxiety feels like? Is this what stress feels like? So it's foreign to me that some people never feel that. Yeah. But the studies are really interesting and they show that, of course, if you're just a stressed out person, yes, it's being accelerated. But if you're not a stressed out person and you react very poorly to stressful situations and you're not able to like digest those emotions or those feelings, that can also trigger quicker biological aging. And it's really unfortunate because, you know, we don't know if like our body doesn't know once we're going through that stressful mechanism of action, if, you know, you just got in a car crash or if, you know, your friend's not texting you back and, you know, that's causing some stress, right? You're kind of, your body's going through that same process and it would, you know, be a lot easier if our bodies could differentiate that, but they can't.
Yeah. But I think but I think this is where things like, whether it's meditation, breath work, some of the very cool technology and devices that are out there available to us right now, whether it's wearing an Apollo Neuro or like whatever it is that resonates for you, right? Taking 20 minutes out of your day and doing a new calm session or a brain tap session. Like, I think what the big takeaway for people here is not to say, if you're stressed, you're screwed. It's more that if you are the kind of person that ruminates and takes stress very personally and has a tendency to hold on to it, it's really important for you to tap into one of these strategies. And so that it's not that the stress isn't going to be there, it's that maybe you're able to manage it a little differently and avoid it affecting you quite as badly.
Yeah, you're exactly right. There's interventional trials that where people are doing, you know, relaxation responses and, you know, basically breathing exercises and meditation before and after that have better biological aging. So I'm definitely trying to work in more of that meditation or things like hot yoga, right, with, you know, calmness for the mind. So it's, yeah, very fascinating.
Amazing. What about exercise? Where does that fit in? Because we know exercise can be a double-edged sword, right? Too much, too little. We got to
exactly. Exercise is really hard when it comes to biological aging. So there's not much on it, but what we know is exactly that is, you know, you want aerobic and anaerobic exercise. You want to be, you know, sweating some days, right? You want to really be doing some HIIT, but at the same time, you want to do that yoga or that stretching or that walking, right? So the Olympic athletes that we test actually, and you know, people who are doing these really high intensity workouts, they tend to have the worst biological aging because they're doing way too much oxidative stress. And whenever I tell people that, they're either like, oh yeah, that makes sense. Or they're like, really? But like you said, double-edged sword.
Yeah. Interesting. Okay, cool. All right. So okay. So telomeres, let's talk about telomeres, because you said something before we started recording that totally captured my attention. And I don't know that I necessarily made that connection, or maybe I forgot about it, but you talked about, let's talk a little bit about telomere length and how you guys measure it. But let's talk about what it really means, because I know that Elizabeth Blackburn won the Nobel Prize for discovering the whole, you know, relationship between telomeres and the Hayflick, not method. I keep wanting to say Hayflick method, the Hayflick factor, whatever, in terms of how many times DNA can replicate. But it's still very fuzzy in terms of, well, what does it really mean to have longer telomeres? Does that mean I'm not going to get sick ever? And, you know, even shortening of telomeres, does it happen when people die, or do people die because their telomeres are short? And then, but you said something about the relationship between telomeres and senescent cell population. So I just dumped a bunch of stuff on you. I need to sit back and let her rip. Go.
Yes. So telomeres have probably been like the most studied hallmark of aging. We're always, you know, adding more of these hallmarks of aging. So we definitely know they're related to the aging process. My hypothesis is they've been studied so much because we still don't know what they do. Right? That's we
Makes
just
so much sense.
Yeah, we're just not really sure. So what TruDiagnostic does is we measure your telomere length based on DNA methylation. I want to make that very, very clear. So all the testing we do is based on that epigenetic DNA methylation. There are different ways to measure telomeres. You know, there's quantitative PCR, there's FISH methods. We will never get as best as FISH method, the fluorescent in situ hybridization. It's where you go in and you like highlight the telomere and you can actually see them and you measure them very, very accurately.
Yeah, you count kilobase pairs, right? Like you literally sit
Correct.
there and go 1, 2, 3, 4.
Correct. So nothing's going to get better than that. But again, people who are doing that, I would question, you know, how are you using that clinically? What does that actually mean? So a lot of these telomere length tests use quantitative PCR. Now, according to the literature, the DNA methylation type of testing is going to have about 2.5 times the correlation to age-related values compared to that quantitative PCR. So I just tell people that because recognize all of these different methods you may be using, and it's not apples to apples, right? You can't compare the two. So let's focus back on that DNA methylation. Now, when we're giving you that DNA methylation, we give you, a biological age based on your telomeres, but we don't like to focus on that because telomeres only make up about 2% of the entire phenotypic aging process. So instead, what we're going to look at is your percentile. So we take your telomeres, we compare you to the rest of our population. How are you comparing?
Yeah.
If you are in the 20th percentile or lower, that's really the threshold. It means that you have more senescent cells compared to people of your same chronological age group. And what that means, remember, those senescent cells are those zombie cells. They're junk. They're not dying. They're causing oxidative stress and inflammation. But what happens is if you come in with a senolytic compound, so these senolytic compounds clear out those zombie cells, it's things like your quercetin, fisetin, resveratrol, tyrostilbene, curcumin. You clear out the senescent cells. Those senescent cells have shorter telomere lengths on average. So you're clearing out senescent cells, those shorter.
So you're improving your average is what you're doing.
So you're, we call it artificially improving your average, right? Which is still great. That's still great to understand. But yeah, that's like the difficulty with, hey, we can elongate your telomeres, right? We can activate telomerase. Oh. We don't really know if that's the mechanism of action that's happening, right? But they're probably those, these supplements and things that are saying that they're probably just acting as senolytics, which is still great. Just a different mechanism of action.
So, but I mean, overall, I guess so. Then you may get a different reading from someone who never uses a senolytic, who has, in a way, a more true representation of their existing population versus someone who did a senolytic course and then did their test like the next week kind of thing. Because in some ways, I mean, it's still a good thing. You've taken out the garbage and you now get a reading on what's left behind. And there will always be some senescent cells behind. We need them, as a matter of fact. But we need some. But to the person who's never done a senolytic before, you're really getting a sense of, what's your universe of what's your senescent cell load
exactly like? that baseline. Yeah. So we are doing some really exciting research with Yale. They actually have a senescent cell predictor using DNA methylation that we're working on. We're fine tuning it a little bit. So obviously when we get that will be more indicative of, hey, here are your actual levels of these senescent cells. But the telomeres right now are a really, really great guide. So we like to use them for that reason.
Okay, so you don't want to be in the bottom 20th percentile on telomere length relative to other people of your age. Are you just comparing age or age and gender?
Just age, so just chronological age, and that's something I wanted to talk about as well because TruDiagnostic has now tested closer to 20,000 people, so super excited about that. But we're comparing you to everyone in that population. And those people in that cohort are usually optimizers, right? It's a very select group of people who choose to take our test. Yeah. There are some of those, Harvard samples from some clinical trials, if we're able to put those in there. So it balances out the line a little bit more because that's going to be more general population. But, you're being compared to the best of the best, right? So just something to keep in mind as well.
Yeah. So that means the bar is high. Right.
Correct.
So if we had 500,000 samples of just the general population, the numbers might look very different. It might be easier to look good in a way.
Correct.
Versus right now, you're kind of going in and comparing yourself against a pretty, again, and it's like you said, right? A group of people who are interested and committed to improving their age. They want to know, and they want to know what they can do better. So right away, it's like looking at any kind of homogenous population versus non.
Exactly. Yeah.
Okay, cool. All right. So I shouldn't be so happy that my telomere age is so awesome. I should be kind of happy because it's better than not, but it only gets you so far is what you're saying.
Right. Just a fraction. We still want to give it some love, but maybe not as much as we once thought we would. But again, I'm sure the studies around telomeres will still, be going on. So we'll keep learning more.
For sure. Okay, so that's our telomere length. So now let's talk about the Dunedin pace of aging,
Yes.
because
Yes.
I love that. That's got the tortoise and the bunny. Turns out in this case, you do not want to be the bunny. You'd way better off being a tortoise, which
Mhm.
I mean, I think most of the time well, I don't know. Sometimes if you're running away from a fox or something, you better be a bunny. But you want to be on the left side of that clock, of that little speedometer.
Yeah.
I guess that's what it looks
Yeah,
like,
definitely.
versus the right. And so maybe talk a
Exactly.
little bit about that, because there's a Dunedin pace study that was done on little children. And we talked about that before the podcast. I'm like, well, wait, can't we change it? And you're like, yes. So
Yeah, no, definitely. This is my favorite one to talk about. It's just so fascinating. Now the first and second generation clocks I mentioned are limited because remember, they're that historical age processing that I discussed. What this Dunedin pace tells you is how quickly you are aging biologically for every one chronological year. So Natalie, like you said, it's a speedometer, right? Which is great. You can speed it up, you can slow it down. Of course, you want to be slowing down your aging.
mm-hmm.
Now, how they created this was from a birth cohort that began in 1972 and 1973 in Dunedin, New Zealand. That's why it's that weird name. I know there's also a Dunedin, Florida. Birth cohorts aren't unique. I'll be the first to tell you that. However, what makes this one extremely unique is they have a 96% retention rate, and it's still going on today. So there's 1,037 people in this birth cohort, 96% retention rate. They're still studying this group. The group's 52 years old today. So very fascinating kind of group of people. But what the researchers did is they're just looking at how this group is aging. At 4 different points in their life, they took all of these multiple system biomarkers, just, think of the most high level things that you could look at on the body. They did, grip strength, balance test, chair stands, physical function, brain MRIs. They looked at their gum health and like their inflammation.
Oh my God.
Just this full panel of everything you would ever want tested on you. And they also took, blood-based markers as well, your typical CBC panels and things you would get from your healthcare provider on your, checkups. So they're coagulating all of this information, looking at how it changes as the group gets older, right? What's correlated with what, and then they're going to use some bioinformatics and statistics and really it's called an elastic net regression modeling system. So how to make something be predictive of an outcome. And that's kind of like a 30,000 foot overview of the study and how they created this outcome. And the outcome, like you said, Natalie, is a number between 0.6 and 1.4. So ideally you want to be at, a standard person would be aging at one biological year per one chronological year. But of course you want to be lower, right? You want to slow this pace of aging down.
Yeah, no, for sure. And then, but what they found with this cohort, I think what's interesting is that didn't they look at them at age, I think it was 2 or 3,
3,
and figured out and looked at what was their pace of aging at that age. And now as they're aging, they're finding that is still true today, right? Like if let's say they were aging in an accelerated way by the time they were 2 or 3 years old, and then as a 48-year-old or a 52-year-old, they're finding that is still staying consistent. Now, the question I had for you, which I think is important for people to get their heads around, because now everybody's sitting there going, well, wait a minute, if I'm over 1, does that mean I'm just done? But don't forget that these people are not getting any coaching. They're not being told to change anything. So they're just going about their lives, doing their thing. Maybe you have some biohackers in that group, like it's big enough a group, and then maybe it'll be down the road. They might look at, well, did any of these people actually take action to slow down their pace of aging? But definitely some of them will be smokers, some of them will be drinkers, some of them will be clean livers, some of them will be super stressed. Like you're going to have a mixed bag. But I guess my question is, if they found that clock stayed consistent through their adult years, is that because none of them did anything to slow it down? Or because my question, of course, is, can't we slow it down?
Yeah, it's definitely changeable. So it's not the pace of aging that was predictive of pace of aging when they were older. It was actually like epidemiological factors. So, at age 3, you take a kid of higher socioeconomic status, right? Compared
Okay.
to, a kid of lower socioeconomic status. So the kid of higher socioeconomic status actually had better paces of aging when they were older, whereas the lower socioeconomic status child or kid had faster paces of aging, pace of aging when they were older. So yeah, not pace of aging to pace of aging, but some type of factor correlated with that at older ages. So
Interesting.
your past can still be an inflection point of that Dunedin pace, right? But it's still absolutely in your control and changeable. Mm-hmm.
Okay. So then that means that those 3-year-olds that had an accelerated pace of aging, there was some stressor on them, whether it was poor nutrition or super stressful home life, or maybe, mom's health wasn't great when they were in the womb, like, or was in a very stressful situation herself, because those associations have been made, right? Like,
it freaks me out to talk about, to be honest. Dr. I'll actually be talking to him Thursday. Dr. Michael Skinner, he is a PhD out of Washington State University, but he studies transgenerational epigenetic inheritance.
That's so cool.
And that basically means, if your grandmother smoked cigarettes, they're going to pass signatures on to your mom. Your mom's passing those signatures on to you. He does his work mostly in mice models and like pesticides and toxins. But when I heard him lecture at PLMI with Dr. Jeffrey Bland in Seattle, Washington last year, I was like, okay, I need to reevaluate, the foods I'm eating, check these labels even further, like really dive into things, because it just, all of this in, your environment, what you're surrounded in, that affects your epigenetic methylation markers, whether you like it or not, right?
Yeah.
Everything is turning those switches on or off, whether it's positive or negative.
And you're passing it. And if you're a mom, you're passing that on to the baby.
Correct.
Right? So guys, in case you didn't miss that little reference there, Hannah's actually launching, or has launched, just not to the big bad world, her own podcast. So if you're super geeky like I am, and you've got, you're just want to go deeper and deeper, she's the one that's going to be interviewing all the scientists and the researchers and the PhDs that the rest of us can't always get a hold of, and have conversations with them. So what's your podcast going to be called? And we're going back to our conversation. We're not done yet, but actually, maybe we'll save that for the end. We'll save that.
Perfect. Let's do that. Let's do that.
Okay, cool. So we've done telomere length. So the other question I had for you is, I recently saw somewhere, and I can't remember where it was, a very enticing graphic that said, oh yeah, okay, so right now we're getting a DNA methylation, like our biological age, based on the sum of our body kind of thing, or an overall reading of the body. But coming down the pipes, and not in the too distant future, we're going to get that aging clock by system and by organ, or certain major systems and organs. So we'll be able to see maybe our heart might be aging a little faster. And that, what's cool about that is that's going to give you and your provider a sense of, well, where do we want to focus our efforts, or what do we want to, why is your heart aging faster? What is it that's driving that kind of thing? So you want to talk to us a little bit about those more specific clocks and how far down the pipes they are? And is that something you guys are going to be bringing to the market? Because
yeah, definitely. That is such an exciting area of research. So I talked about our Harvard trial, after we create a couple of just the I'll call them like basic, second generation clocks. Kind of the second phase in terms of looking at the data is, able to create these system clocks. So telling you, the age of your heart or liver or, your brain, because then that allows for more targeted treatment, right? Maybe your I don't know, heart's a little bit accelerated aging. Okay, well, why could that be? Maybe when we want to do, an assessment or, EKG or, look into it a little bit further. There's some reason that it's aging there. So that will absolutely come down the line, and something we'll offer from our Harvard data, which is so great because, again, remember, we're taking those 5,000 biobank samples and we're able to have, some people are deceased. So we have why they passed away. We have other diseases that they could have got. So we're able to make these kind of correlations.
Yeah.
And our collaborator there, she's great. Her name's Dr. Jessica Lasky-Sue. Her really big passion is in the metabolomic section. So she's amazing and lectures on more of this multi-omic approach quite frequently.
Nice. And so how long do you think before we can get a biological age on our on our parts?
I hope
Roughly.
before.
I'm not going to hold your feet to the fire on this. I'm just curious. Is it like a year, 10 years, a month?
I hope before the end of this year. If it's before the end of this
Okay.
year, I would be super, super happy. Yeah.
All right. So sometime in the next 12 months or so, this should come out. This should come out. Okay.
Correct.
Well, that is super exciting. Okay. Well, okay. So the last piece of the puzzle we were going to kind of dig into a little bit were some of the most exciting trials that you've done as a company, because you guys are always doing really cool trials, and you probably have like a dozen going on now as we speak, where you're doing these IRBs, right? You're basically working with a partner. It could be a supplement company, or I don't know what other types of people you work with, and saying, well, if people do X, how does that influence their Y, right? And you've done a couple of really cool ones, and there's two that we said we were going to talk about.
Yeah, the first one is more lifestyle. I'll chat about that one. That's actually called the calorie randomized control trial. So that study is a 10% overall caloric restriction in healthy non-obese adults over a 2-year period. So, say you have a 2000 base caloric intake level based on your metabolic rate and all these other different factors and your goals, take off 10% of that. And that's what you're going to be holding steady for those 2 years. What we saw is the reversal, or the slowing down of that Dunedin pace, where the control group actually sees an increase. And that is fascinating. And people who are listening are probably like, well, duh, right? We know caloric restriction extends lifespan.
Yeah, but that's not so much. Like 10% is not that hard. Because the old numbers were 30%, which means you're just crabby all the time. But 10% is totally doable.
We never had the data from it until now. It's the first proof of concept clinical trial showing that. And you know what? For that calorie randomized control trial, they did set the bar at 25% to begin. The participants were like, heck no, we can't do this. So they lowered it down to 10%. Obviously, there's going to be people who do a little more, people who do a little less. People who do more are going to see a greater effect, and, vice versa. But so in animal models, we know caloric restriction extends lifespan. Your C. elegans, Drosophila mice, rat models, but it's never been done in humans. So this is a true reflection. We can't measure it in humans because we live too long, and caloric restriction is really hard, right? So the Dunedin pace is being validated by that calorie randomized control trial to really capture true change. So super groundbreaking and exciting.
Yeah. So to summarize, it was just basically over 2 years, these people on average reduced the caloric intake by 10% and saw a slowing down of that Dunedin pace clock. They slowed down the rate of aging.
Correct. And this is, I want to make it clear that as exciting as this field is, it is equally as frustrating, just because it's so new that the interventional data is far few and in between. So I want to make that very, very clear. We're all hyper aware of that. However, what's really great when you do these studies is that you have a cohort, or you have a group, right? You have this baseline, so to speak. So I actually just figured this out the other day when I was talking to Dr. Dan Belsky, who really runs the Dunedin pace. They're doing a 10-year follow-up on these people in that calorie randomized control trial. So something I didn't know, right? Because you have to establish the studies first off, and then you can follow up with them whenever, as much as grant funding allows too.
Right. Well, and I mean, so then you can find out, did they keep up with it? Did they become overeaters? And I guess the other interesting, I mean, if money was no object and you could do whatever, you'd have a group that undereats by 10%. You have a group that overeats by 10%. Everybody would want to sign up for that one until they saw the results. And then you would want to see, what's the delta? Like, how much of an impact does overeating have on undereating? Like, we both know and could probably think of 5 different ways that overeating ages us faster.
Oh yeah.
But like even overeating good calories to a point. But but at some point, nobody's actually done that trial and published that data. Like there's epidemiological information out there. People are guessing. They think it would appear that, it seems, but how cool would it be to run those things kind of concurrently?
Right. Yeah, no, you're exactly right. Because, for example, epidemiologically, we know that a higher BMI is correlated to increased aging, right? They found that very strongly. Do we like BMI as a biomarker? No. But Is it still a correlation? Sure. Right.
Yeah.
So you need those interventional trials. There's very, very large need for those rather than epidemiological.
For sure. Well, and also because BMI, you would then have to split out how many of these high BMI people are carrying extra muscle versus extra body fat, because extra muscle can give you a higher BMI. But truthfully, even more muscle potentially could be faster aging because it's metabolically more expensive. Like, there's a possibility that being over muscular as you age, although it's A, because it's hard to maintain, and B, for whatever other reasons we haven't really elucidated yet, could be a pro-aging kind of
right. A lot of confounding factors, right?
There's so many different things. Yeah. Okay. Now the other one is one I'm actually super interested in because I'm currently choking down, a bunch of supplements and a big tall glass of activated charcoal twice a day. And I want to know what's coming out of this because it sounds like it's worth it. It's worth the labor. So this is the quicksilver trial. Maybe you could I keep getting the name of it mixed up. So maybe you could define it for us and tell people a little bit about what it's about.
Yeah, definitely. So, like Natalie said, it's a 3-month quicksilver, bioage reversal protocol. So pretty cool nomenclature there, but they have, month 1, which is reset. So it's more like detoxification, kind of cleaning out the body. Number 2 is going to be your activate. So, okay, everything is nice and clean now. We're going to go in and start sending these signals and make sure things are working properly. And then month 3 is going to be elevate. So, okay, we're sending these signals, everything's working now. How are we optimizing?
Yeah.
So we did that with, Dr. Chris Shade and his team, and saw really great results, super statistically significant results with the Dunedin pace, and then several of those first and second generation clocks that I was discussing, which again is great because sometimes you won't see, you'll see a positive change in terms of lowering your biological age for a lot of the same kind of generations, but sometimes they're not all statistically significant, right? There's a difference there. So that was a study where we said, wow, this is making a difference. So that was 3 months. I believe it was like 40 to 50 people. Not published yet because we're doing second arm where they're adding, the 40 to 50 people are actually doing another round of something that Dr. Shade wanted them to take that he created. So I forget what even the product's called off the top of my head, but I'm excited to follow up with them and see how that's affecting their aging. So they're going to wait till those 2 arms are done before moving forward with publishing.
All right. I need to find out what that something else is because I'm just going to tack it on to my 3 months. Like if I'm going to go through the misery of doing it this time, I want to add on, bring it on. Okay. Well, anyway, I shouldn't make it sound so horrible. It's actually not that bad. It's just that the activated charcoal, you're pouring a pouch of it into water and you got to keep stirring it and drinking it, guys. Otherwise it puddles at the bottom and then you're drinking kind of mud. The cool thing is it has no taste. So it doesn't taste bad. It's just a little gritty in the mouth. But other than that, it's totally, if you chug it and you make it cold, and the other thing that helps also, if you put a little squeeze of lemon in it.
Oh, yeah.
Like I'm a taste hacker sometimes. If I can put a little squish of lemon in it, it actually makes it taste better. And you just have to keep stirring as you're drinking so that it stays in suspension. and also close the top of your shaker bottle because otherwise it gets all over the place and it will stain. All right. So we're coming up on time and we promised each other that what we would leave people with is some good advice from you. First of all, I think one of the things I'd love to leave people with is if they were going to do something like a TruDiagnostic test, how often would you repeat it realistically? And then you're going to give us a couple of the most, and you kind of already did, but maybe let's circle back to a couple of the most important lifestyle changes that people could make for their health. And finally, if you could only pick a couple of supplements, and I'm not going to give you a number, it could be anywhere between 2 and 4. Okay. What would be the ones, and would they change depending on your age? And you don't have to go through every age group and every supplement stack, but that kind of thing.
Sure. So we have 2 really products at TruDiagnostic, kind of this one called the Complete Collection. You want to do that one every 6 to 12 months. That includes everything, comprehensive, a really great panel. And do that one first. It gives you a good baseline. You can look at everything. The second product is called TruAge Pace. It only includes that Dunedin pace in the telomere length report. That Dunedin pace is so precise, you can retest it every 8 to 12 weeks. So
Wow.
There was a demand for this type of testing, which is why we created it. So it's cheaper as well, and you can retest way more frequently. So those are the two options. Those are the testing windows, the retest windows. Secondarily, my top lifestyle hacks would definitely be lower stress. Regulate your sleep. Sleep is huge, right? Get a tracker, monitor your sleep, really optimize that. Caloric restriction, of course. Following more of, a whole foods diet, no artificial flavorings, foods, the calories that you are choosing to eat do matter, right? You can't go get a McDonald's Happy Meal and say, oh, I've, restricted my calories for the day. Doesn't work that way. Would be cool if it did. And yeah, move your body. I kind of like to say move your body instead of exercising, just because, again, I like to sweat and like sprint and lift weights. I need to feel like I'm like actually kind of, burning that energy, but move your body, take the walks, do the breathing exercises, the hot yoga, of course, alongside with, sprints and definitely weightlifting sometimes, especially as we age, right? We lose that muscle mass. So those are like the 4 top categories. If I were to add another one, definitely detoxify, right? So like women in particular put about 175 toxic chemicals on their body every day, from their makeup, hair. When I found that out, I was like, holy, I did not know that. So also just looking, at that stuff, if you're into it, right? So, definitely can affect your epigenetics. And, supplements, vitamin D, definitely, according to the research, probably 4,000 to 6,000 IU per day. Definitively, that would be my number one supplement. Secondarily would be a methylated B complex, or 5-methylfolate or methylcobalamin. Reason being, I mean, you may want to check in on your, typical pathways, but for people who have MTHFR, women who have the MTHFR 677cc variant, so homozygous there, they actually have increased biological aging. Just there's that correlation there. And if you supplement with a methylated cofactor, you can almost see that instantaneous reversal. So again, it's really cool because it's tying in genetics and like your epigenetics and biological aging.
Yeah.
But I know a lot of people I talk to are on that methylated complex anyways to help regulate some of those pathways. So that looks pretty promising, and one that I am currently taking, but would, probably say is up there as well.
Amazing. So D3, and I would add with K2, because you always want to have your with K2 with your D3 and your methylated B complex. That's 2. That's amazing. And you didn't go into any of the fancy stuff like the like the NADs and the spermidines and you didn't even go there. So that's really interesting. And then what was the third thing? Lifestyle supplement. And I think the last thing, honestly, is going to be where people can find you, where they can find your amazing podcast. I do want to say, guys, that if you decide you want to do either of the TruDiagnostic tests, you can use discount code longevity12, and that will save you some money, and then you can do it more often. But let's have Hannah leave us with her contact information, where we can find her and follow her and her amazing podcast.
Yeah, absolutely. You all can find me at everythingepigenetics.com. That's my podcast name as well, just Everything Epigenetics. And like Natalie said, I'm really diving into what these markers mean as it relates to our health and how we can improve our health outcomes and help regulate our DNA. You can find me on Instagram at everythingepigenetics.com. But if you all want to reach out, just, leave me a message on my website, shoot me an email, hannah@everythingepigenetics.com. You can ask me questions, regarding TruDiagnostic, epigenetics in general. I'd love to chat with you all, but I just really appreciate you, Natalie. This has been, so great. I always have the best conversations with you. I just want to thank you for your time.
Oh, well, likewise. Thank you for coming out. And when, I love talking to you. So it won't be so long next time before, I think when you bring out those individual clocks, we're going to do another episode and kind of dive into those. So once again, it's TruDiagnostic without an S.com. That's a common mistake. I make it all the time.
And TRU, no E.
Yeah, TRU, no E, and diagnostic, no S at the end.com, and longevity12, and then everything epigenetics for everything Hannah. So thank you so much, Hannah. This has been amazing. We'll see you again soon.
Yeah, thank you.